We're now going to try to determine the story that more complex graphs are telling. So some graphs use more than one line to tell a more complicated story. And so here's a couple of examples of that. In the first graph, you see that there's actually 3 lines going on, and in the second graph, there's a couple of lines that are going different directions. So let's delve into each of those. So in this first example, explain the graph in 2 or 3 sentences. So we have to look at what we're being told about. We're told the per capita disposable income spent on food in the United States. So per capita means per person. So it's the percent of disposable income that Americans are spending on their food. And we're told their total food here in red, their food that they're spending at home here in blue, and the food that they're spending, or the amount of their income that they're spending eating out away from home here in green. So what's the story we're being told? We're being told that Americans are spending less of their income on food since the 1960s. So that's the first sort of overall thing we're being told about the graph. Eating at home spending has decreased very steadily. While I'll call it eating out spending has stayed the same. If you wanted, you could add the point that it's the amount being spent at home is very close today to the amount being spent eating out. In the second graph, I'm not going to write out the whole explanation, but I do want to talk about how some graphs look. You'll find that they have y-axes on 2 sides. So there's one y-axis here and another y-axis there. So in this graph, we're basically being shown the violent crime rate per 100,000 residents. This is again an American one, and that's violent crime is this darker line here that starts high and then drops down. So violent crime, you can see, is decreasing steadily since the 1990s. And the second line, which is the gray one, which starts low and goes up since the 1990s, is the foreign-born population percentage. So basically the number or the percentage of Americans that are immigrants. So I won't write it out, but basically what we're seeing is that since the 1990s, violent crime has dropped pretty significantly. You know, going from 750 violent crimes per 100,000 people down to about 350 or so. So that's a really significant drop. Meanwhile, the foreign-born population has also increased quite a bit. And I think what this graph helps show is that immigration does not seem to be causing any increase in violent crime. Those two things don't appear to be linked, since violent crime has been dropping while the percent of immigrants in our population has been increasing. Here's another graph that's showing the rates of autism in Japan. That's the pink line. Compared to the number of measles, mumps, and rubella vaccines, and measles vaccines, which is the blue bars. And the reason I wanted to show you this graph is because this has been in the news quite a bit in the last few years, maybe a little less so now these days, but it used to be thought that there was a link between the number of vaccines kids were receiving and autism cases. And this is one of the graphs that would have been used to make that case, that here in the 1990s in Japan, the number of vaccines given increased, and so did the number of autism diagnoses. But this was basically completely discredited as a real scientific link in the 2000s when they discovered the person who, the main proponent of this, the main doctor who'd been pushing this belief, he had essentially faked a whole bunch of his data and was completely discredited. And so what I want to talk about now is how we find links in data. Here's another graph to compare to that previous one. This is showing that there's been an increase in autism diagnoses here in the darker purple against the increases in food sales, organic food sales, I should say. So is this graph saying that autism is being caused by increasing amounts of organic food? The lesson here is that it's this really classic saying, and I'll talk about these words in a second, but that correlation does not imply causation. That is, just because two trends match doesn't mean that those two things are linked together, that one causes the other. So there's this great website called Spurious Correlations, where they basically compare a whole bunch of random variables together to find these correlations or these matching trends. So here's one where US crude oil imports from Norway correlates very well with the drivers killed in collisions with railway trains. So does that mean that US oil imports from Norway is the decreasing imports is causing fewer deaths from railway trains? No, I don't think so. It's just random chance that these two things were linked up. Here's a similar one. The per capita or per person cheese consumption is linked with the number of people who died by becoming tangled in their bed sheets. This is real data that comes from, you can see the source here, U.S. Department of Agriculture and the Centers of Disease Control and Prevention. So this is real data, and it shows a clear matching trend between increasing cheese consumption and increasing numbers of people dying by becoming tangled in their bed sheets. So there's a correlation between those two. But is one causing the other? Absolutely not. There's no reason to believe that just because these two trends are both increasing, that there's any actual correlation, or I should say cause, between one and the other. And one of the funny things that's happening here is that these axes are basically being manipulated so that the trends match each other in their increases. But if you change the cheese consumption increase or the bedsheet tangling death y-axis, you would all of a sudden, you'd see that they're both increasing, but not that they're perfectly matching each other. Here's another one that I thought was just really funny. The letters, so the number of letters in the winning word of the National Spelling Bee versus the number of people killed by venomous spiders. And you see that the ups and downs and trends of this actually match each other quite well. But again, absolutely no reason to believe that there's any link between those two things. So in the case of increasing vaccination rates and autism, that's basically what we've shown, is that there's no real link between those two variables or between those two trends. There's a whole slew of reasons that autism diagnoses are increasing, and a big part of that is probably just that we're getting much better at recognizing cases of autism, and those cases of autism that are harder to diagnose, we're getting much better at diagnosing those. But here's another graph here that's showing the decreasing rates of smoking here in blue compared to the decreasing rates of cancer, specifically lung and bronchial cancer, which you can see on this axis in orange. And so this is actually a case where we can draw some kind of link between these two decreases. But it's not because of just the decrease matching the decrease. It's because we already have a scientifically proven link between smoking and lung and bronchial cancer. We've already shown that there is cancerous, carcinogenic things in cigarettes that directly cause lung cancer. And so in this case, we see a decrease in the amount of smoking, and we also see a decrease in the amount of lung cancer diagnoses. So in this case, there actually is a causation between, or a link between those two trends.